Hey everyone. Welcome to part 14 of our Python tutorial series. In this video, we'll learn how to create functions in Python with practical examples and also explore recursive functions in detail. Let's get started.
Okay, let's start. Clear, right? Till yesterday what we have done. So similarly, I want to take some functions like we have seen this thing, right? Sum of natural numbers. It's normal basic code. Okay, this code is a basic code. The code what you are using is a basic code. So instead of taking again, just showing you sum of natural numbers. Okay, this is sum of natural numbers. Okay, if you're taking 5, you'll get 15 as output. Natural sum is 15 you're getting. Similarly, if I want to use this sum of natural numbers, instead of going by iteration, okay, this sort of coding will call it as iteration. Okay, without using this, I want to use some functions. Okay, how to create function? Now we'll see how to create a function. We'll have recursive function also. I'll explain you recursive function also. We'll be taking some examples and I'll explain you with that. Okay. Same sum of natural numbers. Using functions. Okay. If you know that C language, how many of you know C language here? Everyone know that C language, right? If you take C language, there will be some declaration, calling, and function. Declaration, calling, and definition. Okay. This is for C language. Even Java also. Okay. Same there we'll use methods, sir. We won't use function. We won't call functions, sir. In Java we'll use methods, sir. Okay. Similarly in Python also, but we don't have any declaration like C language. But we have function call and definition. Okay. How to create a function now? You can create however you want. I'll show you one syntax, sir. I'll take a number. I'm writing like how you do these things in C language. I'm doing that way. I'll take a input number. Okay, any input number from the keyboard. Enter a number. Okay, and after entering, just I want to create a function now. What function? How to create function? By using def keyword. Okay, this def is used to create your, what is this? Like you have a predefined functions and user defined functions. Okay, you have predefined functions. Predefined functions and user defined functions, and you'll understand all these predefined functions and user defined function. I'll be taking a class for inbuilt methods. Okay, and lambda also. For lambda also I'll be taking one class. Clearly I'll explain you what all predefined functions you have there. Okay, what all user defined is like if you are creating some function, it's nothing but user defined function. Clearly I'll explain you these things in that class. Okay, follow all my classes from the starting. We have user defined function. Predefined and user defined function are like predefined function inbuilt itself you have it, and user defined function you are creating it. Okay, if you want I'll give an example. uh, Factorial of 20, this doesn't work. You need to import one package. What was it? Can anyone tell me what package required to take factorial? From max, right? We have mat package. Okay, import max as some m, you can take however you want. Okay, m dot factorial of 20. We'll get this way. I'll take a small number instead of this. I'll take 5. Okay, in this way, this is user defined function. Okay, From some library you are taking it. Sorry, predefined function it is. This is predefined function. From one of the library you are taking this. Okay. From max library you are taking this. But here what you are doing? Okay, you are creating some user defined function. Okay. User defined function. Okay. How you'll get that user defined function? We'll see now. I'll explain you. Okay. User defined function. How you'll get it? Def is used to create a function. Okay. Def of here I'm taking sum, right? Someone. Sum is a inbuilt keyword function for adding something. Don't take inbuilt keyword. Okay. You should not use keywords also. Once search for the documentation of Python, you can find the different keywords. Okay. Here I want to take some number like n. It doesn't mean like anything you can take. Okay. Here you need to create a function now. Like I'll explain you here. Same logic. Whatever logic you're taking, right? You can take the same logic. Okay. This logic creating in a function. Same logic I'm creating in a function. Okay. See how we'll get it. Sum is equal to 0. Okay. For I in range 0 to n here. We are taking n. Okay. Sum plus I. And you need to print here. You can print here or you can return it. Anything you can do. I'll show you in both the ways. I'll print here only. Okay, sum is a inbuilt function. I'll take sum to like that variable. Someone I'm using for this natural sum, or I'll take another thing otherwise. Natural sum instead of this. Okay, easily you can remember. Someone I'm taking. Now see, here you are creating a function and you can enter anything like 45. Or else do one thing. Sorry, where this gone? Okay. Do one thing. First create a function. Now give one hint and call the natural sum. Okay. I'll explain you all the things, what is calling and everything. Okay. Number. Now see, I'll take 5. You're getting 15. Okay. Sum of 15 is this, right? Here, this is nothing but definition. Okay. Definition of any user defined function. Okay. This is definition of user defined function. And this is nothing but calling. You'll call it as calling a function. Calling a user defined function. Okay. Even if you are passing num here, okay, you'll it will consider as and you can take any variable here. Okay. So this num is passed to this function. Okay. And same, you know this logic, right? This logic we have used previously. Okay. This is how your user defined function works. And you can take, however, natural sum of 10 also you can take. You get the output. You can use this way, user defined function. You can create it once, you can use it multiple times. For every time, it's not required for you to use this logic, right? Okay, if you create this once, you can use it multiple times. Okay, this is nothing but sum of natural numbers using function. Here, you are printing here. Okay, you are printing here, but you can do one more thing also, one more coding, like with return type. Okay, sum of natural numbers, okay, using functions with return type. You know, when you take C language, you'll have void function and all, right? It's same way. But here is like you are taking some return type function. Here, instead of this, I'll take a return type. Okay. I'll show you like what you'll return. Return someone. Okay. Now see, whenever I'll take natural sum, okay, natural sum of 7, it will return 28. It means it is returning some value here. Okay, clear? Getting it right? Even you get this way. It is with return type. Even you can take here also. If you want, you can copy. Or here you can take a int of input, enter a number. Okay, you can use this way. From 5, you'll get this way. Okay. Now, one more thing. I want to show this sum of natural numbers using function we are doing. I want to show by using some recursion. Okay. Sum of natural numbers using recursive function. What is this recursive function? Try to understand. It is also important. Okay. Same will create same sort of function, but logic will be totally different. Okay. Def natural someone, same, you'll take one of the input. Okay. And here I'll create a different logic. See, if n equal to 0, okay, or n equal to 1, at this time I'll return n, will return n. Okay. Else, see this logic, how I'll do. Else return n plus natural sum of n minus 1. Okay. Now see, if I take any number like see input value or anything. Okay. Now see, natural like someone here. Now run this code. I'll take one thing. See now. Natural someone, okay, of some 5. Run this and see what you'll get. You'll get 15. What is happening? Okay. What is happening here? Why it is faster? Recursive is always faster. Okay. And you'll have less time complexity. Okay. You'll have less time complexity as compared to iteration and this function. So recursion will have less complexity. Okay. What is happening here is like, I'll tell you, you are sending this 5, right? Here 5 will come here. 5 is not like, it will not come into this loop. Why? Because 5 is not equal to 0, 5 is not equal to 1. It will come here. At that time you'll get 5. 5 plus, you are taking natural sum 1 of n minus 1. Means again you are calling the same function. Okay. You are calling the same function. So again it is entering here. So again n is equal to 0, n is equal to 1. It is not true. Again it will come here. Again you will get 4. 4 plus recursion function like natural sum of 4 minus 1 is 3. Again it will come here. Again you are calling this. 3 is coming here. Okay. Same condition up to 3 plus 2. Okay. Same condition you'll get. When it is 1, it will return only n. Okay. Here your loop will end. This is how you'll get the recursive function. Okay. So 5, 4, 3, 2, 1. If you add, you'll get 15. Clear everyone? Still any doubt here in this recursive function? How we are getting this recursive function? Any doubt? Even understanding this is also very important. Recursive function is also very important. Okay, clear or not? Hello. You can ping in the chat, so I'll be knowing whether you're understanding it or not. When you're taking recursive function, how to take it. Yeah. Okay. This is related to the sum of natural numbers using recursion function. In the same way, you can take for factorial is easy. Okay. Easily you can take the factorial. Same. If you take factorial code, okay, previously in day 4 we have taken right factorial. Okay, this we are using for factorial. Okay, I'll show you. Initially we'll move with the iteration. Factorial. Okay, factorial code. If you give 5, you'll get 120. Okay, by using inbuilt method, I have shown you how to take it. Okay, you can also take this way. This predefined function you can use. While we are dealing with lambda, I'll show you for factorial, we can take 5 different types of coding. I'll show you different sort of codings. Okay. With lambda, I'll show you for factorial, we can take 5 different types of coding. I'll show you different sort of codings. Okay. See, in this way you'll get same 120 are getting, right? So similarly, using functions will take factorial using functions. Okay, how to take this factorial using functions? Okay, I'll tell you now. See, same create same logic. Here mostly you'll have the same logic. Okay, with return type or without return type, mostly you'll have the same logic. Okay, see here, instead of natural sum, I'll take factorial. Okay, fact of n. I'm taking fact of n. Fact of n. Okay, fact is nothing but a user defined function now. Now you need to take fact. Okay, we don't have any factorial, right? Okay, so you can take fact is equal to sum1 as I shown you previously. Okay, instead of sum, take factor. This logic I have explained to you yesterday itself. Okay, what happens if you take factor? Instead of addition, you need to take multiplication here. Okay, what you need to return? Fact you need to return. Same like previous one. Huh? And what is a user defined function name here? Factorial. Okay, now see if you take 5, you'll get 120. This is nothing but user defined function. Now I want to take some recursive function. Okay, same thing I want to take recursive function. Okay, factorial using recursive function. Okay, same logic. What we have done here, it will be almost same, but a small modification. Okay, see, we won't use this. I won't be using this. I'll use the same logic. Like if n equal to 0 or n equal to 1, n equal to 1, okay, at that time you'll return 1. Same, how we are using that logic, we are doing the same thing. Okay, else what you'll do, factorial of n, n into factorial of n minus 1. How we are taking n plus factorial, right? N plus sum you are taking. How we are taking here, see, how we are taking this n plus sum of n minus 1. Similarly, I'm taking this here also. N into factorial of n minus 1. Similarly, like 5 into 4 into 3 into. Okay. Until and unless it is equal to 0 and 1, you'll take n into factorial of n minus 1. Same thing you'll take. Okay. And here you are taking factorial, right? I'll take factorial 1 here. Why? Because you already have it, right? Previously. Okay. Now run it. It's showing an error. Error is factorial 1. Factorial 1. Okay. N is equal to 1, return n, else n into factorial 1 of n minus 1. And what's the error? Let's see. Unsupport. Okay. Here we are taking factorial of sum of n plus 1. Okay. We'll see now what's the error here. Okay. Now we'll take 5. Still it's raising an error. Need to see what was it. If n is equal to 0, n is equal to 1, you return this. You should not get an error. Hint and non-type operand. Yeah. What might be the error here? Can anyone tell me? N is equal to 0, n is equal to 1, you are returning n. Otherwise, you are taking n into factorial 1 of n minus 1. Logic is correct. Okay. And okay, fine. Let me see here if it is showing anything. Factorial 1 of some 5 I'll take. It's raising an error. This sort of errors na sometimes it may raise because of my updation of my Jupyter notebook actually. Okay. Why? Because logic, if you see the logic is correct actually. Same thing, I'll show you some online Python compiler. Why? Because there is no logic. If you check it, we can see we don't have any error in that code. Okay. But once I want to cross check with the code, factorial 1, it's correct only. Factorial 1, factorial 1, everything is correct. Okay, n into factorial of n minus 1. Correct only. Code is correct only. We are taking 5 into this. So why we are getting error? We'll run it and see. Okay. Why we are getting this? We'll run it and see. Here we need to print. It's a Python notebook. You're getting that without printing. But if you want to print it here, you need to print. Okay. Factorial 1 of. Take any number 5 and see now. Okay. Sometimes it shows some error. Where it is showing else. Indentation is correct. Unsupported operand type. Line 5. We are taking a number itself. It is not taking any input here. Let me check it in ChatGPT. I don't know why it's raising an error something. Recursive need to work here. Whenever you get some sort of this thing now. Okay, I'm not taking return here. So, sorry, I forgot to take return here. Sorry, that's the only mistake what I've done. Okay, we need to give return type, right? When you're creating something like you need to give return type. Here in this recursive function, you have given return. I did not return. That's the reason I'm getting error. I'm just looking at the logic actually. Logic is correct. There is no mistake in logic. Okay, here we forgot to give that return type. Okay, clear right till this recursive function, everyone. You're understanding what is recursion, what is a function, what is iterative code. Okay, how you're getting all these things.
Thanks for watching. Practice these examples and let me know. If you have any questions in the comments, stay tuned for part 15. Don't forget to like, share, and subscribe.